Hey, welcome back to my YouTube channel. After so long, I'm making this video just to walk you through the design of this very complicated Android board. Okay, so this is the 3D view of the board that I designed. Okay, and we can also flip it over. So this is the bottom side. Okay, this board incorporates TDA4VM processor, and then 4 GB LPDDR3 memory and 16 GB eMMC memory. Okay, so let's go through the design involved in this board design. So let me go to the 2D view. Okay, so here's my 2D view of the board. Okay, let me make it single layer mode view of the board. So this is the top layer. This is a porting layer board design. Okay, and in this design, all the high-speed both single-ended and differential fair signals are routed strip line. Okay, just to reduce the EMI interference and some noises. Okay, so this is my solid ground plan. Okay, here's my signal layer where I designed this data lines. Okay, all right, this is again solid ground plan, and on this layer 5 I designed this high-speed signal lines, as well as differential fair DQS signals of the data byte lengths for this LPDDR3 memory interfacing with the processor. And we have some other signals and then power rails. On layer 6 I have this solid ground plan for referencing the high-speed signals, and adjacent to it we have this different power rails. Okay, again here we have power rails. This is power rail, and on this layer I have this high-speed 100 ohm differential fair signals for MIPI CSI camera interfacing, and then address command control and clock signal for LPDDR2 memory interfacing with the processor. And then we have some power rails on the side. And the most importantly that I want to tell you in this to the video is particularly this routing. This is not as simply um, feedback signal. This is just a pseudo differential pair. Now you've got to see how the pseudo differential pairs are routed. Okay, you just route feedback lines along with two ground signal lines. I mean the ground lines all the way to the power management IC from the middle of this processor. Here we had a processor. Okay, so this is the pseudo differential fair routing. Here we also have pseudo differential fair routing for the feedbacks of this power rails. As you can see here, this is routed along with these two ground signal lines. Not the signal, ground lines. This is kind of shielding this feedback line. I guess this might be the first time for you to notice this kind of routing. The pseudo differential fair routing for the power line feedback signals. Okay, and right after that we have this solid ground plan. Again, on the next layer number 12, we have this differential fair routing with time delay matching, and then some others command control and command and control single-ended signal lines. And then here we have some single-ended signal lines. And then we have here is again, it was actually the dedicated for the power ground layer, but the problem is that I could not be able to complete the power rail routing on the power front, so I had to route the remaining power rail on this layer. And right after that I have this bottom layer. This is simply the ground layer, I mean the ceiling for some signals, and as well as the reference for this. So this is it. This is a very small form factor board, and I'm kind of happy because I could complete routing, and then they complete the placement of all the critical components within these small form factors. Okay, and thank you for watching this video, and I do hope you have understood how the pseudo differential fields are rooted. And because this video was specially for you to show you guys how the pseudo differential roads are rooted. Okay, so that's it, and thank you for watching this video.